putting data centers in space. I mean, it sounds like something straight out of a sci-fi movie, right? But believe it or not, some of the biggest names in tech, we're talking Google, Amazon, SpaceX, they're actually seriously considering this as the next big frontier for AI. It's a wild idea, so let's dig in and figure out what's really going on here.
Yeah, see? This isn't just some fantasy concept. It's being thrown around as a real solution to the enormous problems our data centers are causing right here on Earth. And that, of course, leads to one very big question.
That is exactly what we are going to unpack. We're going to look at the physics, we're going to look at the ergonomics, and the pretty brutal reality of trying to put the cloud, literally up in the clouds. So, first things first, why are we even thinking about space? What's so bad down here? Well, to put it simply, we're kind of running out of Earth.
The AI boom has kicked off this incredible, almost frantic land grab. We are now building AI supercomputers the size of actual cities. They consume gigawatts of power. I mean, whole power plants worth of energy. And get this, we're literally draining rivers just to keep millions of GPUs from melting down. But the real bottleneck? It's time. Here on Earth, land is finite, the power grid is tapped out, and just getting a permit to build can take years. And if we really need 100 times more computing power by 2030, well, something's got to give.
And that's where space enters the picture. It looks like this perfect, almost elegant answer to all of our messy problems down here.
And you can see the appeal, right? It's undeniable. In orbit, there are no property lines to worry about. And if you're in just the right spot, you have this constant, powerful, unfiltered fire hose of solar energy just blasting you 24/7. It sounds so clean, so infinite, almost poetic. But this is exactly where that beautiful dream smacks right into a hard wall of physics.
Okay, so here's the reality check. It turns out putting a data center in orbit isn't just difficult, it's what you might call a thermodynamic trap.
And the single biggest problem isn't launching it. It's not even powering it. It's something way more fundamental, something that almost everyone gets completely wrong about what space is actually like. So here's the paradox. We all know space is cold, right? Incredibly cold. So cooling down a computer should be a piece of cake. It should be free. Well, nope. That one simple misunderstanding is probably one of the most misleading ideas in engineering.
This right here, this is the scientific principle that basically unravels the whole concept. Yes, space is freezing cold, but a vacuum is a near-perfect insulator. Think about it. Here on Earth, air molecules or water can bump into a hot server and carry that heat away. That's called convection. But in space, there's nothing. No air, no liquid, nothing to carry the heat. The only way you can get rid of it is to radiate it away as infrared light. And that process is incredibly, painfully slow and inefficient.
So what does that inefficiency actually look like in the real world? It means you need gigantic radiators. I mean, huge. To cool just a relatively small 40-megawatt data center in orbit, which is about the size they're proposing to start with, you would need about 120,000 square meters of radiator panels. That is the size of 20 football fields, dedicated only to getting rid of heat.
And believe me, the cooling problem is just the tip of the iceberg. To power that same facility, you'd need solar arrays the size of city blocks, weighing in at around 400 tons. Then you've got radiation, a constant storm of high-energy particles that will corrupt your data and just slowly destroy your hardware. Latency is a killer too. Even in low Earth orbit, you're looking at a 10 to 50 millisecond delay for a signal to go up and back. That's already way too slow for a lot of real-time AI. And maybe the biggest hurdle of all, you can't fix anything. If a chip fries, it's just space junk. You literally have to launch with 2 or 3 times the hardware you actually need, just hoping enough of it survives.
So let's do some quick back-of-the-napkin math. You add it all up, 400 tons for the solar panels, another 400 tons at least for those giant radiators, plus the weight of the actual computers, you're easily looking at over 1,200 tons. At today's launch places, you're talking about $6 billion, and that's just to get it off the ground. That doesn't even count the cost of the hardware itself. All right, so if orbit is that insanely hard, what about the next logical place people talk about? The moon. I mean, it's a solid surface, right? That's got to be easier. Well, this is where the problems go from just being difficult to being almost impossible. This chart really lays it out perfectly. First, latency. It jumps from milliseconds to 2.6 seconds. That makes any kind of real-time work a complete non-starter. Then radiation.
The moon has no atmosphere, no magnetic field to protect it. Your hardware is just completely exposed to raw cosmic rays and solar flares. And then, the real killer, the night cycle. A lunar night lasts for 14 Earth days. That's 2 straight weeks with 0 solar power.
And on top of all that, you have to deal with these unique lunar killers. The dust there is this fine, abrasive, electrostatically charged powder that gets into absolutely everything and shorts out electronics. The temperature swings are just wild. From over 120 degrees Celsius in the sun down to minus 130 in the dark. That causes constant stress on every single component. And to survive that 2-week night, you'd need either impossibly huge batteries or, you guessed it, your very own nuclear reactor on the moon.
So yeah, it really does feel like a trap, doesn't it? The physics, the logistics, the sheer cost, it all just seems like a dead end. But is there any way out of this? After hearing all that, you'd think the idea is completely dead on arrival, but it's not. The key is, we have to stop thinking about space data centers as a replacement for the ones on Earth. Instead, we need to think about what they could do that data centers down here simply can't.
And that's where a few really specific niche ideas actually start to make some sense. Not for running ChatGPT in real time, but for storage. Think of it like a doomsday vault on the moon, something a company called Lawnstar is already experimenting with to back up humanity's most vital knowledge. Or maybe as a sovereign data backup for a country that wants a truly off-site, secure copy of its national records. The common thread here is that you don't need to access the data quickly. It's all about long-term, secure storage.
And that really sums it up perfectly. For this to go mainstream, it's not just one thing that has to change, it's everything. Launch costs have to collapse. We need brand new radiator technology. We might even need a whole new type of computing that generates way less heat. It's not impossible, but it's a long, long way off.
So we kind of end up right back where we started. For right now, this dream of having infinite, clean computing power in the sky is mostly just a thermodynamic trap. But as our demand for data and AI here on Earth just keeps growing exponentially, you have to wonder, at what point does solving all those massive challenges in space actually become easier than solving the ones we've created down here?